is a good thing in case you miss a day of class or something like that. So this was number 10 yesterday. It's the only thing I asked you to do for homework. I just asked you to try it, and you got credit if you did. Looking at number 10, okay, we're going to get to the recursive and explicit equations in a second. What mathematical representation did I leave off of here that would have been pretty easy to create? A table, right? So don't forget, we can always create a table. And I think tables are one of those things that can be very helpful in writing an equation. By the way, Jamar, you're supposed to be in group 5. I know. I realized it. Alan was gone yesterday, so he didn't know. How do I have 12 students, but I only have 8 cell phones? Who forgot to put theirs up? I'll go through the list if I need to. Yes, sir? Alright. Jeffrey, 26. And McKay, yours was 23. Okay. So let's see. Jamari, where's your phone?
I ain't got one.
Jamari, don't lie to me. Put your phone up.
I ain't going, man.
You realize, like, I have 9 students who easily put their phones up without complaining. Let's not even give yourself a chance to be distracted. Put your phone up.
Cause they green beans.
No. Hey, Jamari, your number is
Oh, you got
Four.
numbers on here stuff.
yes.
Hey, bro.
That's how I knew that yours wasn't up there.
I could never be a green bean.
Okay. Yeah, I think that's everybody. Okay, maybe I'm missing one person, but I think that's everybody.
Say where your phone at?
Zay's is up there. Zay is number 16.
Alright. Stay where your phone at?
Who?
Stay.
Donovan? His is up there, number 8. Why are you trying to call everyone else out? Worry about you, man. Alright. So looking at number 10, yeah, we can very easily make a table here, and I will say making a table can be very useful in writing equations, okay? So notice when the input is 1, you're looking at 10 and a third. However, I will point out, how in the world did I know it's 10 and exactly 1/3? What type of sequence is this? Arithmetic, which we know that because of the linear shape, right?
I'll put that down.
You got that part, that's why I gave you 1 point out of the 5 for the homework. Give you a little bit of something, right? You got something there.
Oh, I'll do my homework. Hold up. Let me just
So, it's linear, which means it has what type of rate of change? Not just constant. Everything we've studied is constant so far. It's called a common difference, I believe. Meaning that we're repeatedly subtracting the same amount every single time. Well, it's not easy to tell what it is to here, but Donovan, you and I talked about this, and I talked about it with the whole group. If I look at these 2 points, I can very clearly see it's going down to the right 3. Rise divided by run. A common difference is the same thing as a slope. Okay? So notice I could have gone straight to the point 3, comma 8, 9. Is that 9? Yeah. And so that's how I know that my slope is negative 2/3. And so then 2 would be at 9 2/3. And I can keep this pattern going to figure out the rest of the points. And is it 6, 7? Sure is. Right, so we can see those different points there. but we know it's arithmetic, we know it has a common difference in negative 2/3. Now, Cheyenne, I think this is a safe thing for everyone to say, the hardest part about the sequences is doing what part? Writing the equations, right? That's totally, I get it, like that's 100% the hardest part about this stuff. Now, this is also why I said, and especially for those of us who were remote or were remote and then came back to school, if you did not have a fantastic 9 weeks last 9 weeks, I told you that this 9 weeks we are actually doing the same stuff, except we're going to go into Unit 2, which is on specifically linear and exponential functions. So if you show me on the unit test that you have learned how to write these equations, write these formulas and things like that, and understand linear and exponential functions, I'll go back into last 9 weeks, I'll talk about it with Mr. Hinton, and I'll do a grade change for him so that you can earn a 50 for the last 9 weeks, because a 50 is way easier to recover from than, say, a 20 or a 10 or a 0. I care about your learning, and so I'm going to reward the learning that you do.
Are you sure you're gonna go for that?
I literally talked about this yesterday.
I'm saying, but you know you're gonna go for it for sure.
Like, will he go for it?
Yeah.
He's done it with me before, because he and I both care about students learning, and so it is way easier to recover from that 50. So if you can show me that you learned how to do this, I'll reward that learning. Okay? So when I look at this, I will say, and if you're struggling to write an explicit equation, I would always write a recursive first. If you are struggling to write an explicit equation, I would start with a recursive. This is a recursive. F of n equals f of n minus 1. What does that really mean? F of n equals f of n minus 1. What does that really mean? Don't everybody shout at once. It's not like we haven't studied this for a whole 9 weeks. Say it again, Caroline. Does a recursive equation relate inputs and outputs? Say it louder. Current and previous values. Right? This would be my current value. This would be my previous value. The way we know that is if I was looking at f of 5, right? We have f of 5 right there. Notice how that 5 is my n value. So what would 5 minus 1 be? 4. So this would be f of 4. So f of 5 somehow relates to the one just before it, the previous. That's what we mean when we say current and previous. We use variables to represent anything. So f of n is my current value, f of n minus 1 is the previous. So what am I doing to the previous value to get to the current one? What is that rate of change? It is a common difference, but what is that common difference here? Which is? Negative 2/3, right? You have to be able to identify what is the rate of change so that you can move forward. Hey, I'm repeatedly subtracting 2/3. I know that because I subtracted 2 over a span of 3, or my rise divided by the run is negative 2/3. So what am I doing to get to the current value from the previous? I'm subtracting 2/3. That's it, right? That's my rate of change. Is it enough to define a sequence just by the rate of change, though? What else do you need? You got to have a starting point. Whether it's a recursive equation, whether it's an explicit equation, whatever it is, in order to define the equation, you got to have a rate of change, you got to have a starting point. So notice, I defined it here. Is that the only place I could have defined it? No, I could have said f of 3 is equal to 9. That's what this point is. Could have said f of 6 is equal to 7. I could have chosen any starting point. I traditionally start with the y-intercept if I have it. Okay? Because when I get to my explicit equation, and this is where it does get a little tricky, you have to keep in mind what f of n and f of n minus 1 mean for a recursive versus what f of n means for an explicit. Right? When I say f of n and f of n minus 1, that's the current output equals the previous output. So f of n is just what in general? Remember, f of n was the current what? Current output, right? So f of n in an explicit is just in general my output. We don't worry about current and previous with an explicit equation. Remember, with a recursive, we're relating current values and previous values. With an explicit, we're relating inputs and outputs, right? Recursive, it's only outputs. For an explicit, it's inputs and outputs, right? So f of n, the whole thing would be my input, because what am I plugging in? Just the in? Don't you just plug in what's on the inside? So f of n my output, n is my input. Now, notice, looking at the recursive, what is the starting output? 11. So where did I start my equation? At 11. The output f of n equals 11. That's where I'm starting. And what is repeatedly happening to that 11? Notice I started at my 11 and I'm subtracting 2/3. And most students just memorize equations because that's what you're used to, that's what you were taught. But all of these equations have meaning to them. Whenever I'm repeatedly adding or repeatedly subtracting, what mathematical operation can indicate repeated addition and repeated subtraction?
Multiplication.
Say it louder.
Multiplication.
Multiplication. Notice I'm repeatedly taking away 2/3. It doesn't just happen once, it doesn't just happen twice, it's going to keep going. So I'm multiplying that by a variable because it can change. The fact that I can repeatedly add, repeatedly subtract is the reason that I'm multiplying and I have to multiply by a variable. We're going to continue practicing writing these equations with what's 1.9 and 1.10. We didn't get to do that before the end of the 9 weeks, but that's going to be the introduction into Unit 2. And hopefully this will help us all get onto the same page before we start that Unit 2. Sound good? Alright? Any questions before we move forward? Does that help answer some of those questions? I know, it's still unfamiliar, but does that help start answering some of those things? No. So today's objective, or today's agenda, we'll look at the objectives in a second. We're going to look first at the objectives. One of the fundamental things I need you to understand is it is hard to learn what you need to learn if you don't know what you're trying to learn. It is hard for you to learn what you need to learn if you don't know what you're trying to learn. I don't put these objectives up here for my health, I put it up here for your safety and sanity and everything going on in your brains. So, we'll then get to what does it mean, 1.9, the launch and the small group work, and then we'll wrap up the day. We only have one objective today. Jamari, can you read our objective for today? You don't feel like it? Man. Okay. Who read yesterday for the objectives? McKay did? Mona, can you read today's objective?
No, I'm gonna do it.
You can get tomorrow, Jamari. Hey, Jamari, you had your chance? You can do it tomorrow. Mona's chance now.
I can use principles of arithmetic sequences to find arithmetic means, missing values, and arithmetic sequence.
Okay.
What you
So,
said?
hey, leave it alone. One thing I want to point out. Hey, Jamari, stop running your mouth. Stop trying to cause issues, man. So I want you to notice one thing really important is this comma right here is starting what's called in the positive. So I can use principles of arithmetic sequences to find arithmetic means, and I'm clarifying what an arithmetic mean is, right? Or what do we mean by that? Missing values in an arithmetic sequence. So when I talk about an arithmetic mean, because we've talked about means before, haven't we? You've never heard of a mean?
I have.
Not in here, but in general, what does a mean? Okay? Mean, median, and mode, but mean has another word that we should know. It starts with an A. Say again? I thought someone said it. Average. When we talk about a mean, what we're talking about is an average, right? So we're trying to find arithmetic means, or the missing values in an arithmetic sequence. There are a few different ways to do this, and you'll discover it hopefully talking with your groups. So here's what we're looking at. What does it mean? It's a solidifying understanding task. Each of the tables below represents an arithmetic sequence. Why is it important that it's arithmetic? What does that tell you? It's going by what? It's adding and subtracting, which, what is the additive rate of change called, McKay? Common difference, right? So we know that we're either adding or subtracting. By the way, I passed these out earlier. Did anyone not get 1.9?
It's probably.
I'm sorry. There you go. Alan, did you get a copy of 1.9? Get out, we're about to do it. Okay. So we need to recognize that these are arithmetic sequences, so they have an additive rate of change, a common difference. So within your groups, I'm going to go ahead and just launch you into number one. I want you to start talking about how you might approach this problem to find what the answer is, or what this missing value is for number one here. And I believe it goes through number 3, yeah. So go ahead and work numbers 1 through 3, and then try to answer 4. But do not go ahead of that. We will talk after I feel like we need to talk about number 4, okay? So pause at 4, or don't go beyond 4. We'll gather together about that time.